Hi everyone, it's James here, and in this tutorial we're going to be doing some hard Edabit challenges. So these are tricky, they're going beyond the beginner challenges that we've looked at in the previous tutorials, and there's one challenge at the end which is really practical. I can imagine you using the code in your own projects. So keep watching till the end of the video so you see how that challenge works out. But let's dive into the hard Edabit challenges now. Okay, so hopefully you know how Edabit works now, so let's crack on straight with these hard challenges. Just before we start, if you do have a second, don't forget to subscribe to support the channel and so you don't miss out on any future tutorials. So the first one I've picked out is this one called 7boom, and strange name, but essentially what it's saying is you're going to create a function that receives an array, and there'll always be numbers, and you've got to check whether the number 7 is present anywhere in the array. So with this first example, 7 is the last number in the array, so we return this boom string. But you can see this next one, it doesn't have the number 7, so we return this string, there's no 7 in the array. And for this final example, although there isn't a single digit 7 in the array, 97 does actually have the digit of 7 in there, so we still return this boom string. So basically we're checking to see if anywhere in this array there is the number 7. Okay, so let's have a crack at this one. As usual, I'm just going to do a simple solution to start off with, just to talk you through the process, and then we'll come up with some ideas of how we could make this a bit more streamlined. So here's our function, and we've got the array being passed in. So the first thing I'm going to do is just create a variable in this scope of the function, and I'm going to call it result. And I'm going to set it to a default value of saying there is no 7 in the array, which is the text we want to return if we don't find a 7. So the next thing I'm going to do with the array is just loop through each item in the array. So we could say let I equal 0, and we're going to keep going until we've reached the array length, and we'll iterate one position at a time. And then I want to check if each of these items, the numbers that are being passed in, whether they contain a 7 or not. So it's not really a case of just saying if the number equals 7, so if array item is equal to 7, because as we saw in the final example, we want to catch numbers that actually have 7 within them. So we could do some crazy maths operation with this potentially to work out whether or not the number does actually contain a 7, but I'm not great with maths, and that's probably not the best way to do this. So what we could actually do is convert this array at position I into a string, and then just check if the string contains the number 7, because you can't do that with a number. So let's first of all change this array item into a string, and there's different ways that you can do this, but I prefer to use the string method to actually put this into a string. So let's put the array item into there, and then we can write our if statement again, but this time instead of just checking the number itself, we'll say array item string includes the number 7. And if that is the case, then what we'll do is we'll change the result variable that we've got, so that's this local variable up here in the function, and we want to change it to the text boom. And of course we can break out of the for loop as well, because we don't need to keep checking the rest of the items in the array. And when that for loop's completed, we'll just return the result. Okay, so let's check that, and we should get some passing tests for this function now. Okay, so that's the straightforward way to solve this challenge, and there's nothing wrong with this solution. It's very readable, you can see what's going on. But I don't like creating local variables like this that you have to then update. It does introduce room for error if the function gets a bit more complicated. So there are some other ways that we can handle this. The first thing I'm going to do is use an array method to check if the item actually has the number 7 in there. So let's just delete everything that we've got here. And I might as well convert this to an arrow function here as well. Because what we can do is we can actually just do an implicit return here and use the sum function on the array, which, if you haven't come across this before, basically returns true or false, depending or not on whether any of the items in the array match a certain condition. So if one of the items in the array do match the condition that we're going to put into the callback here, then we'll get a true result, which is really handy for our situation because we might want to return the different types of strings depending on that true or false result. Okay, so we'll do the same thing again that we did. We'll take the item in the array and we'll just coerce it to a string, and then we'll just check if it includes 7. So this will be true or false depending on the result, and then we can just use a simple ternary operator to say, based on that true or false result, to say we'll return the string boom, or there is no 7 in the array. Okay, so that should be enough for us to pass all of the tests again, but there's an even simpler way that we can approach this as well. This way is still, I think, quite readable because we're using the sum function, which it's quite clear what we're doing here. But instead of looping through the entire array and then checking for the existence of a 7, what we could do is take the array and convert the whole thing to a string and then check if that string includes the number 7. So the way we would do that is just to take the array. And there are a few ways that you can convert it to a string, but I'm just going to call the toString function, which is available on the array. And then all I need to do then is just check, does that include the number 7? And of course, then we'll need to actually put our ternary operator back in there again. I probably shouldn't have deleted that because we need that here. So we still then need to say boom. Oops, I've pressed the wrong button. And then there is no 7 in the array. Okay, so if we run the tests again, that should all pass. But this time, we're just taking the entire array, converting it to a string, and then just checking if that string has the number 7 in there. And then based off of that result, we can then display the correct response to the user. So if we just click Submit Final, that should pass all the tests again. And there you go, you can see all of the tests passed, and we've now completed that challenge. So just to recap on that one, there's different ways to approach it. The first solution was fine, but there was some local variables which might cause us problems if the function gets more complicated. And the one-liners that we did, the implicit returns, I don't think there's much difference between them. I would wager that the last one that we did, where we converted the whole array to a string, is probably a bit better for performance. So we'd probably go with that as our final solution. Okay, so let's finish up that one and go to the next challenge. So another one I've picked out here is this number of boomerangs. You've probably come across what a boomerang is, but in this example, a boomerang is essentially a sequence of 3 numbers where the last and the first numbers are the same numbers. So, for example, here we've got 373, so 3 and 3 are match, so we've got a boomerang. Here we've got 1 and 1, which match, and 5 and 5, and you get the idea. So we need to create a function that actually checks how many boomerangs are in an array. So we might get an array like this coming in, for example. So again, we've got 3 and 3, 1 and 1, and I think 2 and 2. So I think that's 3. Yep, and there's 3 boomerangs in this sequence. So that's basically what our function needs to do. And a note here as well, just saying that if you've got 3 which are identical is not a boomerang because the middle digit is identical as well. So we need to be careful of that. So let's go over to our code and write some examples for this. So I'm going to do a similar thing that I did in the previous example. Let's have boomerang count, and we'll just initialize that at a value of 0. And I'm going to loop through the array. So I'm going to say let I equal 0, and we're going to keep going until we hit the array length again, basically looping through the entire array. Okay, and essentially we're going to be incrementing the boomerang count by 1 when we find a boomerang. So we just need to write an if statement to check when we've actually found that. So let's just open that up and then we'll fill that in a second. Okay, let's put that inside there. So within our for loop, we've got the index of the item that we're currently looking at in the array. This is the current, or will be the first item to start off with. And we want to check if that is the same value as the array item that's 2 positions forward. So if we go back and look at one of the example arrays. So here we're looking at the 0 indexed item, and we want to check this one here to see if it's the same. So we'll do that by saying, is this array item here, is that equal to I plus 2? And as our for loop runs through, we'll move through the array just checking each item at the position. And of course, this will actually go out of bounds of the array, but JavaScript's quite forgiving in that respect, so it will just give us some null values, and this equality match here will just fail, so we won't actually get any more boomerangs. So if we run that now, oh, I didn't actually return anything from there, so let's just do that. So return boomerang count, so actually give us some values. This should pass some of the tests, but some of them will fail as well. I'll explain why in a second. So you can see here we got some values back, And the reason for that is if we look at the first test, we'll probably find that, yeah, for example, here, there's 3 items which are the same. So this will actually return a boomerang. But if you remember that special note at the end of the challenge, this should not be considered as a boomerang because this middle number is exactly the same. So we need to put another check in for that here too. So we'll say, and the array item at position I plus 1 is not equal to the current item that we're looking at position I. So that will just account for checking this middle value here. And if we run the checks again, you can see they're now all passing. So this is one possible solution for this. Again, I don't like using variables inside of a function scope like this and then having to update them, just because it introduces some room for error if the function does become more complicated. But I think this if statement here, although it's a bit clunky and a bit ugly, it's probably the most expressive way of illustrating what we're trying to do. So if someone else is reading your function, they'll kind of have a good idea of what you're actually trying to count and what exactly a boomerang is. But we can neaten this up maybe with an array function, because we're dealing with an array here. So let's get rid of our existing function that we got for our solution. And again, we'll probably change this into an arrow function, because why not? Enable us to use an implicit return, because we're just returning the 1 value. Okay, and to work with our array, we're going to actually just reduce it into a single number. So what I'm going to do for that is use, obviously, the reduce function here. And I want to access a few things within the callback. First item is the accumulator. So this will be the overall count of boomerang counts. In fact, let's actually just call that boomerang count like we did in the previous tutorial. And then we've got the actual item itself. And I also want to keep track of the index of the item that we're looking at in this example too. So that'll be quite relevant for our if statement that we're creating. So the callback here, let's just tidy this up. We'll actually initialize the boomerang count at 0 as we did in the previous example. So for each iteration of the array that we're going through, we're going to return the boomerang count, which is essentially our accumulator. And then instead of doing an if statement inside of here, just to neaten things up, I can say, is the item, is that equal to the array that's been passed in? And we'll get the item in the array at index position plus 2, as we did in the previous example. And also, we want to put that other check in to say, I hope that the item at index position plus 1, that's the one in the middle of the boomerang, is not equal to the item. And I think you can just see that there, yeah. And that's just a different representation of the if statement that we had in the previous example. So here we're reducing the array and keeping track of the boomerang count, and then just adding the result of the expression here to the overall count and then returning that from the array. So if we just submit the final result there, you can see all of the tests are still passing, and that just gives us another way of representing that if statement and not having to use a for loop to loop through the entire array. So that's another solution for that one. It's up to you which one you want to go with. But I think for this challenge, those are both fairly valid solutions. Okay, so let's have a look at one more challenge for this tutorial. Okay, and as I mentioned at the start of the tutorial, this one is actually quite relevant because it's something that you might actually need to do in a project. It's very unlikely you'll be counting boomerangs or outputting the word boom for a particular function, but definitely trying to work out how many days are between 2 dates. That's something that is quite useful to know. And I feel like this is a really practical example that you can take away. So let's just quickly run through the challenge. So essentially you're creating this getDays function, and it's actually going to be passed into date object. So you don't need to actually worry about converting the values that are passed into a date. We could put some checks to make sure they are dates, but just for this example, we're going to assume that everything is passed in as a date object. And then based on those 2 dates, we just need to return the number of days that have passed since that date. So this is a bit tricky because the dates could be in any order. It looks like the examples they've given, they're all in order. So the first date is before the second date, but it could be that they're the other way around. So we need to make some provisions for that within our function. Okay, so let's go ahead and write our function now. So the first thing I'm going to do in this function is convert both of the dates into timestamps. Now, if you don't know what a timestamp is, it's basically the number of milliseconds that have passed since the Unix epoch, which is a date back in the past in 1970, 1st of January to be exact. So if I was just to create a new date object now, so I'll just call it date D, and then just create a new date, we get an object like this. But it has loads of functions available on it, and the one function that we're going to be using is called getTime. And you can see it returns this really long number, which is basically the number of milliseconds that have passed since that date I just mentioned. And there is also another function as well called date.now, which gives you the number of milliseconds that have passed until this point right now. So if I was to run that, for example, you can see that this is a few seconds more, a few thousand milliseconds more than the date object that I just created a moment ago. So we don't need to worry about date.now for this example, but just date.getTime will enable us to get a very specific number of when that date occurred for the date object. And it makes it a lot easier to compare these values if we're comparing two dates. So there are other functions available on the date object, but this is going to be the most useful for us for this example. So let's just convert both those dates to start off with. So I'll say date1 stamp for timestamp is date1.getTime, and I'm going to divide it by 1,000 to convert it from milliseconds into seconds that have passed since the Unix epoch. So date2 stamp is equal to date2.getTime, and again divided by 1,000. So we need to work out the difference between these two date stamps to get the number of seconds difference. So let's create a new variable called difference. And it's basically going to be date1 stamp, and then we subtract date2 stamp. So this will give us the number of seconds difference here, but we actually want to get the number of days. So we could create another variable here called number of seconds in a day. I'm sure you can think of a better variable name than I can there. That'll do. And 86,400 seconds in a day. So all we need to do now to get our difference is to actually, let's just group these together so that we know that we're dividing this by the right number. And number of seconds in a day. Make sure I spell the variable right. So this will basically subtract the two date stamps from each other and then divide it by the number of seconds in a day, and that should give us the difference between the two date stamps. But we might actually get a fractional number here, and we probably want to return a whole number. If I look at the tests, so they need to be whole numbers that we return. So there are various math functions that will enable us to do this, but I'm going to choose the math floor function, which will basically round the number down, because a whole day won't have passed if we've only got a fraction of a day there. So let's just return math.floor. And now if we run that with the tests, and yep, of course I've spelt it wrong because I had a complicated variable name. Let's say seconds in day. That'll do, because I won't make any spelling mistakes there now. So let's run that again. We've got to get rid of our errors. So that's actually given us all of the right results, but they're actually negative values rather than the positive integer values that we wanted. And this goes back to what I was saying a moment ago, that you could get dates that are in the past or the future mixed up in each particular argument position. So we could obviously just change these round into date1 stamp and date2 stamp, and that should pass our tests. But what we're probably better off doing is actually using the math.absolute function, which will actually remove the negative value from the result that we get here. So we can put these back in the same position. And that way, no matter which date is in the future and which one is in the past, we'll still get the same result. This will consistently remove the negative value, and the difference will always come back as a positive. So if we check that now, you can see all the tests are now passing because we've got the positive values coming back from our absolute function. Okay, so this challenge has been really useful. It's given us the opportunity to learn a bit about date and time in JavaScript, and there's not much we can do to refactor this. We could try and squish it all onto one or two lines, But I think we'd really be forcing our code into an ugly position if we were to do that. There is one thing that I would suggest doing with this. I'm just going to, obviously, you can put it into an arrow function if you want or not, it's up to you. But we've got a bit of repeating code here where we're calling this get time and then dividing it by 1,000 on both these two variables. And that's not too bad for this function because we're only calling it twice. But if we were dealing with multiple dates or maybe even an array of dates, then this would get a bit cumbersome. So what we can do in here is maybe just create another function. I'll say called get timestamp, for example, and it's going to take a date object. And it's a function itself, so it's going to just return the get time divided by 1,000, and then instead of calling it manually here, we can just say get timestamp and date 1, and then get timestamp date 2. So this might look a little bit weird having a function inside a function, but it's perfectly normal. And as I said, if you were going to be calling it multiple times or passing it into an array function, then this would make sense to keep your code all in one place and not having to repeat yourself. Okay, so let's just check that all still works and submit the final version. And whoops, I forgot an equal sign here just to make sure that's assigned into the variable name for get days. Okay, so all our tests are now passing and we can submit that final result there. Okay, so that brings us to the end of this video, these hard Edabit challenges. Hopefully you didn't find them too taxing. I think there's only a small jump up from the medium ones that we were looking at last time to this. And hopefully you've learned some things about array methods and also working with date and time in JavaScript. So let me know in the comments below which your favourite challenge was, and if you have a different solution, feel free to share that too. And don't forget to subscribe to support the channel and so you don't miss out on any future tutorials. Thanks for watching, I'll see you next time.